Hi, I'm John Carter.
And I'm Theo Mossman.
We're presenting on Water Efficiency Credit 3, Cooling Tower Water Usage, which is a brand new credit for LEED version 4. The intent of this credit is to conserve water used for cooling tower makeup while controlling microbes, corrosion, and scale in the condenser water system. Refer to the definitions below if you're unsure of any of these terms. Scaling and corrosion cause a need for components in the system to be replaced, which is costly and also not environmentally friendly.
To give you a little bit of background on cooling towers, please refer to the diagram to the right. Evaporating water leaves behind dissolved solids which cause scale and increase the chemical concentrations within the system. To prevent this buildup, water must be cycled and replaced with makeup water through a process called blowdown. A blowdown can use thousands of gallons of water, which is bad for water efficiency. Efficiency, in this case, is measured by the number of recirculation cycles between blowdowns. For cooling towers and evaporative condensers, a one-time potable water analysis must be conducted to measure the levels of the 5 control parameters. These parameters being calcium, as calcium carbonate, total alkalinity, silicon dioxide, chloride, and conductivity. The actual levels of these control parameters are used to calculate the maximum number of cycles between blowdowns. We will look at an example of this on the next slide. An analysis of the makeup water for a cooling tower revealed the following concentrations shown in Table 3. Dividing the maximum allowable concentration by the makeup water concentration, you obtain the number of cycles allowable for each parameter. For example, calcium has a maximum allowable concentration of 1,000 parts per million, and a makeup water concentration of 100 parts per million. This yields a value of 10 cycles between blowdowns. This is an okay value. However, we must look at the other parameters. For example, alkalinity has a maximum allowable concentration of 1,000 parts per million, but a makeup water concentration of 200 parts per million. This yields a value of 5 cycles between blowdowns. The minimum number of cycles from this analysis becomes the maximum number of cycles between blowdowns. So in this case, the maximum number of cycles between blowdowns is 5 cycles.
To earn points for this credit category, you must achieve the following. For 1 point, you must have a maximum number of cycles achieved without exceeding any filtration levels or affecting operation of condenser water systems, up to a maximum of 10 cycles. For 2 points, you can achieve a minimum of 10 cycles by increasing the level of treatment in condenser or makeup water. Or you can meet the minimum number of cycles to earn 1 point and use a minimum 20% recycled non-potable water. Non-potable water can be used to reduce the amount of potable water used in your cooling tower. The sources of non-potable water, however, should have low levels of dissolved solids. Stormwater runoff, for example, is not a good source of non-potable water due to its high level of dissolved solids. Some good sources of non-potable water are air conditioner condensate, rainwater, steam system condensate, food steamer discharge water, fire pump test water, and ice machine condensate. The required documentation for this credit categories are as follows. For 1 point, you must provide potable water analysis results, potable water analysis narratives, and the cycles of concentration calculations. For 2 points, you must additionally provide non-potable water calculations, water treatment calculations, and non-potable water analysis if using 100% non-potable water. Again, I'm John Carter.
And I'm Theo Mossman, and this should be all you need to know for the LEED GA. Good luck!